Hi everyone, and thanks for joining in today's lecture. Today it's going to be our lecture number 7 on time series analysis and forecasting. So let me do a quick recap of what we have already done. So we were studying about some important covariance stationary processes, and up till now we have already covered what is a white noise process, and then we have moved into the autoregressive processes where we understood what is autoregressive process of order 1, what is autoregressive process of order p, and then after finishing this we have gone into the moving average processes. Also we have seen moving average process of order 1, moving average process of order q, and moving average process of order infinity, right? So we have already covered these things. Today what we will do, we will move a little ahead and we will combine the autoregressive processes and the moving average processes together, right? So we will combine the autoregressive process and the moving average process together, and we will study something called the ARMA process. We will study something called the ARMA process, and we will consider the general versions of it. We will consider the general versions of it. So AR, the degree is P, and for MA the degree is Q. So we will study ARMA process of order PQ, right? So this is what we will learn in this lecture. So let me start with the definition. ARMA is autoregressive moving average processes, right? Autoregressive, so A, R, and moving average in A. So again what I have told you, this is ARMA process of order PQ, right? So let us start with the definition. A time series process, a time series process YT, a time series process YT is said to follow an ARMA PQ process, an ARMA PQ process if it can be written as now. If you have followed my lectures on autoregressive process and the moving average process, you will know how we write them individually. You know how to write ARP and you know how to write MAQ. So you have to just combine both of them. Let's see. YT, what will this be? Alpha plus phi 1 YT minus 1 plus phi 2 YT minus 2 and phi p YT minus p, right? This is the AR part, and then what you do, plus the MA part, epsilon t plus theta 1 epsilon t minus 1 plus theta 2 epsilon t minus 2 and this goes on up till theta q epsilon t minus q, right? Where this epsilon t's follow white noise with mean 0, variance sigma square, theta naught is 1, and the coefficients, the intercept terms and the slope terms. So alpha, phi 1, phi 2 up to phi p, also theta 1, theta 2 up to theta q, they are all some constants, right? So this is the definition of autoregressive moving average process or the ARMA process. So what we do, we first include an intercept term which is alpha, and then we write as it is the ARP process, phi 1 YT minus 1, phi 2 YT minus 2 up till phi p YT minus p, and then plus the MA process, the MAQ process, which is alpha epsilon t plus theta 1 epsilon t minus 1 up till theta q epsilon t minus q. So we are literally just adding the AR process and the MA process in order to get the ARMA PQ process. I hope this definition is clear to you. Now what we can do, we can combine the terms to write it in a compact way. So this can be written as I from 1 to p. Then you have phi I yt minus I plus summation j from 0 to q theta j epsilon t minus j. Again theta naught is 1. Right? Okay. So here this is going to be the AR part, ARP, and this is going to be the MAQ. Right? I hope this is understood. And now what you can do, you can write it in this way also. I from 1 to p phi I. Using lag operator, what will this expression be? Lag to the power degree I yt. So this I have told you multiple times. If you haven't seen my previous videos, I will give the link in the description so you can check that out so that it becomes clear. So this is what we have. And now what we do, here you have yt and here also you have yt. So if you take yt common and take this expression on the left hand side, what you will get? I from 1 to p phi I L to the power I into yt. So this is basically you are taking yt common from these two expressions, so you will get this. And on the right hand side you have as it is 1 to q theta j L to the power j epsilon t. Now if you again have seen my videos, I have told you this is the characteristic polynomial and this is also the characteristic polynomial. So what you can write, and this is a function of only the lag operator L, because phi's are constants, which I have mentioned in the definition here, that all the thetas and all the phi's and alpha, these are all constants. So this term in the brackets are in the function of L only, right? L only. So we write it as capital phi L into yt as it is, and here you write alpha plus, this is expression of only L, again theta j L to the power j summation theta j L to the power j. So you write it as capital theta L into epsilon t. So this is capital phi L, this is capital theta L. So I have individually described them when I taught you the AR process and the MA process. So now since I am combining them together, so you will have both these terms, right? Capital theta L and capital phi L. So this is what you have. This is what you will get. Now, where this capital phi L, which is 1 minus summation I from 1 to p phi I L to the power I, is called the characteristic polynomial. It's called the characteristic polynomial of ARP process, and capital theta L is simply summation j from 0 to q theta j L to the power j, which is simply this term, right? This is the characteristic polynomial of ARP process, and this is the characteristic polynomial. This is the characteristic polynomial of MAQ process, right? This is clear. I hope I have explained the concept to you, and I hope this process is clear. Okay. Now the most important thing that we learn for every other covariant stationary processes that we have learned so far is under what conditions will the process be stationary. So we'll see under what condition ARMA process is stationary. Now one thing you must know, that MA, the only if you consider this MA portion, MA is always stationary, right? Under any, when I taught you this moving average process of any degree you consider, MA1, MAQ, or MA infinity, in any case, MA process is always stationary. So we are not concerned about the MA process. We are only concerned about the AR process, right? We are only concerned with this AR process, and if this AR portion is stationary, then we'll say the entire ARMA is stationary, and if it is not stationary, we'll say ARMA is not stationary. So again, I am repeating what I told you, is that MA process is always stationary under any parameter values, right? So we are not concerned with the MA part in case of checking stationarity of ARMA process. So we'll only see if this AR portion is stationary or not. If it is stationary, the entire ARMA is stationary. If it is not stationary, then entire ARMA is not stationary, right? So let me write it down. And how do you find stationarity of AR process? Again, if you have seen my video, you will know what will be the criteria. All the roots of phi z. Phi z is a nothing but this characteristic polynomial that I have told you here. Characteristic polynomial of ARP. So instead of lag, you write the z. You replace that with a value z because you are trying to find out the roots eventually. So if all the roots of phi z equals to 0, lie outside the unit circle, irrespective of the values of MAQ parameters. That is, what are the MAQ parameters? Theta 1, theta 2, up till theta q. Then the process is stationary, right? Then the process is stationary. So these are the MAQ parameters, as I have told you, irrespective of the values of MAQ parameters. Since MA is always stationary, so we are not considering them for any which values of this MA parameters. If we find that the roots of phi z equals to 0 lie outside unit circle, suppose this polynomial here, this is a pth degree polynomial. Since it is ARP process, so we will have phi 1, phi 2 up to phi p here, right? So it's a pth degree polynomial. AR here, phi z equals to 0 is a pth degree polynomial, so it will have p roots, right? It will have p roots. Suppose the roots are z1, z2 up to zp. So these are the p roots. We will assume that this AR process or this AR characteristic polynomial will have. So what we will say, for stationarity, each of this root, the absolute value of each of this root has to lie outside the unit circle, or simply have to be greater than 1 for all I from 1 to p, right? For all I from 1 to p. So if we see individually all the roots lie outside unit circle, that is absolute value is greater than 1, we will conclude that the ARMA PQ process is stationary, otherwise it is not. So graphically or visually, if you want to see, this is what I am trying to say. Suppose you have something like this, and this is the unit circle. Unit circle means the circle which has a radius of 1, right? This is simply the unit circle. So what I am trying to say here is that the roots, the p roots here, will lie outside the unit circle. So it can lie here. Suppose this is one root, suppose this is another root, this is another root, this is another root, this is another root. So all the roots has to lie outside the unit circle. It cannot lie within the perimeter of this circle, right? So this is the circle with radius 1. This is the unit circle. All the roots, if all the roots lie outside unit circle, that is the mod value is greater than 1, strictly greater than 1, then we will say the ARMA process is stationary. I hope this is absolutely clear. Now moving on, the final thing that we show for every process that we study is that for a stationary ARMA process, so for any meaningful explanation or the usage of the processes, I have told you stationarity is very important. Even if a process is non-stationary, you have to first convert it into stationarity, then only we can derive something meaningful out of that. So we'll assume that this process is stationary as of now, and then we will try to find out what are the characteristics in terms of mean, in terms of variance, and in terms of the auto covariance that we always do. So let's start with the mean. Firstly, write the process alpha plus summation I from 1 to p phi I yt minus I plus summation j from 0 to q theta j epsilon t minus j, where theta naught is 1 and epsilon t follows, white noise 0, sigma square. So this is the process. Now, since the process is stationary, so we can ignore the time point. So expectation of yt has to be equals to expectation of yt minus I for all I from 1 to p. This is the same process as we have done multiple times. When I taught you AR process, I told you that in case of MA also, in any process you follow, if it is stationary, you can write it in this way. You're ignoring the time points because at time t or in time t minus I varies from 1 to p, the expectation or the characteristics have to be the same. So suppose this mean is mu. Now simply you have to find this value of mu. So what you will do, you will take expectation here. This is the original process. Take expectation both sides. So what you will get, expectation of yt. Here what you have, expectation of alpha is alpha only. So write as it is, plus summation I from 1 to p phi I, and then you have expectation of yt minus I. So I have taken expectation here, summation I from 1 to p phi I, expectation of yt minus I plus. Now if you take expectation here, what you will have, expectation of epsilon t minus j, which is nothing but 0. But still let me write it. Theta j, expectation of epsilon t minus j. So this term will be 0, so you may not write this thing. So expectation of yt is mu plus summation I from 1 to p phi I, and then again this thing is mu. So what you can do, you can take mu common from these two terms. So you will have 1 minus summation I from 1 to p phi I, and here you have alpha, so mu, or which is nothing but the expectation by t, is alpha upon 1 minus summation I from 1 to p phi I, right? So this is the expectation of the ARMA PQ process. I hope this is clear. This is the absolute same thing that we do again and again. Now for finding out the variance and the auto-covariance, I have to write alpha in terms of this. Alpha is mu into summation I from 1 to p phi I. So simply I have multiplied this with this, right? Okay. Now let us find out the variance. So yt. So if you start with this original thing, alpha has to be replaced by this. This we find out. So this, let me write 1 minus summation I from 1 to p phi I mu plus summation I from 1 to p phi I yt minus I. This is as it is. Rest of the thing will not change. Summation j from 0 to q. Then you have theta j epsilon t minus j, right? Okay. Now simply yt minus mu. So here you multiply mu and minus, you will have summation I from 1 to p phi I mu. So take this mu to the left hand side. And here, if you see these two expressions, here you have summation I from 1 to p phi I, and here also you have summation I from 1 to p phi I. So if you take this summation I from 1 to p phi I common, you will be left with, firstly you have this positive yt minus I term and minus of mu. Right? I have just taken this term out, summation I from 1 to p phi I, and the rest of the terms is as it is. Right? In this way. And then you have summation j from 0 to q theta j epsilon t minus j as it is. Now why I have done this? This is the same process for finding variance which I have told you multiple times. Now what you do, on both sides you have to multiply by yt minus mu. So yt minus mu square. So both sides you have to multiply. So what will this be? Phi I y t minus I minus mu into yt minus mu plus summation j from 0 to q theta j epsilon t minus j into yt minus mu. Right? Now if you take expectation, next step is taking expectation on both sides. So expectation of yt minus mu square is nothing but variance, which is gamma naught. Now if you take expectation here, what you will have is that summation I from 1 to p phi I. Now expectation of yt minus I minus mu into yt minus mu. What will that be? This will be gamma. Now I have told you how to do this. Just subtract this thing, t minus I minus t. Right? Take these two suffix and just minus. That will be here as the lag of gamma. So what will this be? Minus I. So gamma minus I is again exactly equals to gamma I from the properties of stationarity. Again, if you haven't seen my video on stationarity, check that out. I have told you why this will hold. So here simply we can write gamma I. Right? I hope you got the process. So expectation of this into this. So that will be in the covariance format, right? That will be in the covariance format. So basically gamma I plus summation j from 0 to q. Then you have theta j into expectation of this. Right? This is what you have. Now I want to give you a very small homework. Your homework is try to find out what will be this expression. Let me give you a reminder that this will not be a very, good looking expression. It will be a very messy expression. That is why I am not deriving it further. If you want, you can, simplify this. But the variance, this is the, what you have as the variance. Up till this much, this is fine. But this portion will be very complicated and messy. And you don't need to, write that down. But still, for your convenience, you can try your hand at this problem. I'm giving you this as a homework. But if you know the process up till this is more than enough for you. So for variance, what you have to do is that firstly you have to find out the mean, because from mean you will get the expression for alpha, and then on the original expression you have to replace this value of alpha, and then if you simplify you will land up to this expression. And this expression itself is very messy, and if you can try it on your own, but it will be a very messy expression. I am not deriving this any further. If you have any doubts in this, you can let me know and I'll help you out in that, right? So now we will straight away go into the auto-covariance function, right? Auto-covariance function. I hope this variance part is clear. If you have any doubts, you can let me know in the comment section. If you know this process, then everything is all right. Now for auto-covariance, let me write it down. Show that for ARMA PQ process, gamma H will be phi 1 gamma H minus 1 plus phi 2 gamma H minus 2 plus phi P gamma H minus P if H is greater than Q. And for all other terms, For example, for age in between 0 and q, this expression is again, that will be very messy and we will not go into that, right? So we will focus on only those things which we can use it for our purposes. For other things, the complicated ones, we will not go into that. And if you know the process, I'm again and again repeating this, if you know the process of how to do this, then that is fine only, right? So you have to focus on the process. So let me do that. So we'll start from this expression yt minus u, that we have this found out earlier. Yt minus mu is what? Summation I from 1 to p phi I yt minus I minus mu plus summation j from 0 to q theta j epsilon t minus j. Now we will use our regular process. We will multiply both sides by yt minus h minus mu, right? This is what we do, and we'll do this on both sides. I from 1 to p phi I yt minus I minus mu into yt minus h minus mu, and then plus summation j from 0 to q theta j, this, and yt minus h minus mu. Right, now what you have to do, simply take expectation on both sides. If you take expectation here, this will be nothing but gamma h. That is why we follow this process, right? Now if you take expression here, expectation of this into this, again you have to see this thing, t minus I minus t plus h. So tt will cancel out and you will be having only h minus I, and we will see what will this be. So let me write, gamma h is summation I from 1 to p phi I, and then you have gamma h minus I. This is what we got here, h minus I, and plus summation j from 0 to q. What do you have? Expectation of theta j, expectation of epsilon t minus j into yt minus h plus mu into summation j from 0 to q theta j, expectation of epsilon t minus j. So what I have done is that I have gone inside the brackets and multiplied with each term. So first time I have written summation j from 0 to q theta j epsilon t minus j into yt minus h. So this is one part, and in the second part, summation j from 1 to q theta j epsilon t minus j into mu, right? So this mu will come out here and you will have this, right? Now epsilon t follows white noise, so this expectation will be 0. So what you will have, I from 1 to p phi I gamma h minus I plus this expression j from 0 to q theta j, expectation of epsilon t minus j into yt minus h. Okay, now the question is, what will be this expression? If you look carefully, expectation of epsilon t minus j yt minus h will be 0 if h is greater than q, and it is not equals to 0 if 0 less than equals to h less than q. Now how did it came from? If you look at this expression, let me write it, expectation of t minus j yt minus h. This is what we have. Okay, now we know something, we know this thing, that epsilon t yt minus j is 0 for all j greater than 0, right? This is, we know, this is the thumb rule which I have told you multiple times before. Now here you have, instead of t, you have t minus j, and one thing you know is that j denotes the parameter values of MAQ process. So this is from 0 to q basically. So from the original equation also, when I have given you the definition, so this j varies from 0 to q basically. Okay, So j varies from 0 to q. Now if y, the suffix of y has to be less than, less than q, basically less than t minus j, sorry. So I hope you understood what I am trying to tell you. So t minus j, so this thing has to be less than t minus j in order to this have to be 0, right? So if h takes the value, so if h takes the value, say q plus 1, so what will this expression, this will be epsilon t minus j, and here into y t minus q minus 1, right? This will what you get if h is equals to q plus 1. So if j can maximum take the value q, right? Even if you take the maximum value of j t minus q, this expression is still less than that, and that is what we want. We want this kind of a thing, right? So t minus j, here if you have t, here you need to have positive j in order to make it 0. So here you have epsilon t minus j, so here you will have to have something which is less than t minus j. Now j can take the value from 0 to q only, so it has to be in this format, right? T is minus q minus 1. Or if you take h is q plus 2, anything greater than q, anything greater than q if you take, then you will see this will be t minus j y t minus q minus 2. So this is again 0, and this will continue. So for any h which is greater than q, this expression is always 0. That is what I am trying to tell you. And if you do it on your own, you will understand it better what I am trying to tell you. So remember this thing, this is the thumb rule, and this is the logic what we are using here. So this term is basically 0 for every h greater than q. So what will be the expression for gamma h? Let me write it down. So gamma h is simply summation I from 1 to p phi I gamma h minus I for all h greater than q. So we simply write this portion, right? So this is 0, so only write this portion, and this is nothing but what we need. So this is something h minus 1 plus phi 2 h gamma h minus 2, and in this way if you continue, this will be phi p gamma h minus 2 for all h greater than q. And this is what we started. So this is, I have written here that show that ARMA process, for ARMA process this has to be the expression for gamma h or the auto-covariance function, and that is what we are able to prove, right? So I hope this explanation is clear to you. So let me give a quick recap of what we have done. So firstly, we have defined what is the ARMA process, ARMA PQ process, and how you write it, and then we have explained this in terms of the lag function. So we have derived the characteristic polynomial for AR process and the MA process, and then we have combined it to write it in this way. And then we have seen what is the condition for stationarity of this ARMA PQ process, and finally we have seen how to find out the mean, the variance, and the auto-covariance function. Since it's the nature of this function is a little complicated, the characteristic features, that is the mean, variance, and auto-covariance, that those expressions will also be a little complicated. But for specific ranges, so here we have seen that for specific range h greater than q, this auto-covariance function has this specific form. So you can try to find out what will be the expression for this, and that will be very complicated in nature. So but for your convenience, you can try your hand at this. But if you know this processes only, that will be enough for you as of now. And if you have any doubts anywhere, you can let me know in the comment section. And thank you very much for joining in, and stay tuned for the next video where I will be going into what is ARMA and SARIMA processes. So I'll see you there. Thank you for your time.